Hello, everybody. I'm Dr. Bob Morris, professor of biology at Wheaton College in Massachusetts. Welcome to another episode of Science with Dr. Bob. Today, we have a delicious episode for you. You know, I love chocolate, and chocolate is made from cacao. And you may have heard that cacao is super high in antioxidants. Those antioxidants are good for you, and you may have heard that from me on an earlier segment. Well, I wonder about antioxidants. What is an antioxidant, and how do antioxidants work? That's what our experiment is today. That's what we'll be talking about. Antioxidants, they're a kind of molecule, and you may know that molecules are made up of the smallest bits of matter, of atoms. Atoms assemble into molecules, and molecules assemble into macromolecules. And that's the level at which antioxidants work, at that molecular level. We humans, we are living organisms. We are beautiful interconnecting webs of chemical reactions that make us and sustain us. And we, like all other animals, support those chemical reactions with food that we use as fuel and as building material. Our cells break that food down into its smaller parts and assemble those parts back into complex molecules that they build themselves. It works like this. We take in high complexity, high energy molecules like proteins and complex carbohydrates, and we break them down into simpler, low complexity, low energy molecules like, for example, amino acids and simple sugars and even eventually carbon dioxide. And we collectively call these breakdown reactions catabolism. But we also use these lower complexity, lower energy molecules to assemble back into complex molecules again. And we collectively refer to those assembly reactions as anabolism. And together, all the chemical reactions of our bodies are collectively referred to as metabolism. Meta meaning beyond. And all of that biochemistry generates a kind of molecular exhaust. Those are waste products of metabolism. Some of those waste products are ones we use, like heat, for example. Heat is a byproduct of those breakdown reactions, and we warm-blooded creatures use that heat to maintain our nice, comfy, steady temperature for continuing metabolism. But some of the molecular waste products can be damaging. In particular here, I'm talking about reactive byproduct molecules called free radicals. Free radicals are a natural byproduct of metabolism, but they can do damage to our other molecules, our normal healthy proteins, and lipids, which are actually fats that make our cell membranes, and DNA, damaging them in reactions that are called oxidations. And this is where the name antioxidant comes from. An antioxidant is a molecule that will neutralize those damaging, pesky free radicals so that they don't go around doing damage to other molecules in our cells. A free radical, when it attacks a molecule and damages it, it actually creates another free radical, and you'll get a chain reaction of damaging molecules. In fact, this free radical damage idea is one of the leading theories to explain how it is that animals age. A buildup of free radical damage is known to occur in animals over time, and in very small, short-lived animals like flies and worms, reducing oxidative damage either by increasing their antioxidizing enzymes or feeding them antioxidant compounds can extend their lifespan. These results are not as straightforward in more complex animals like mice or other mammals, where it appears that more processes than free radical damage are at play in the process of aging. But we do know that free radicals can cause damage to molecules in our cells. That damage can be chain reactions. Damage to molecules can accumulate over time. And 3, that accumulated damage to molecules can lead to diseases. So then we can hypothesize that 4, antioxidants may help slow this damage and may then slow some of the natural processes of cellular aging that can lead to disease. So there's the background on what is an antioxidant. It's a molecule that neutralizes those pesky but naturally occurring free radicals that can cause damage inside our cells. That chain reaction of a free radical creating damage in another free radical is actually stopped by an antioxidant, which plugs up that free radical and stops it from doing its damage. So that's where our experiment is coming from today. We have an example of that oxidizing reaction that you may be very familiar with. The browning reaction of fruit is actually an oxidizing reaction. So let's do an experiment on that. Very simple experiment. Here's the idea. In the browning reaction of fruit, colorless, higher energy molecules called polyphenols are oxidized by an enzyme called polyphenol oxidase, or PPO. That creates molecules of brown pigment that are less tasty, less nutritious, and less attractive than the unoxidized polyphenols. So if we add an antioxidant, it should block the oxidation reaction and result in no production of brown pigment. And the antioxidant we're going to add today is vitamin C. It's also called ascorbic acid. So it's thought that plants have evolved this oxidizing reaction partly to protect themselves. Let's do that reaction today. Let's start that experiment today. So the apple has polyphenols that can be oxidized to pigment and the enzyme polyphenol oxidase, PPO, separate from each other in healthy cells in separate compartments. If we just cut into this apple, we start the browning reaction. We now have sets of broken cells where the PPO can get to the polyphenol and the browning reaction can start. But if we take an antioxidant, like the vitamin C that's in this lemon, and we just cut off a section of lemon and put that antioxidant onto the apple. Now we're also adding acid. Citric acid is going to slow that reaction down too. But here we have ascorbic acid, vitamin C, an antioxidant, and an acid that are slowing down the reaction on this half of an apple. And this one has all the PPO and polyphenols getting to each other and starting a browning reaction. If we just let that go about a half an hour, here's an example of what that will start to look like. Here's the apple that I have. There's an apple I cut about a half an hour ago, and there's the section that's already been browning where the PPO can get to the polyphenol. Here's a half an apple where I just covered it with ascorbic acid and citric acid, and the antioxidant has helped to slow down that browning reaction. And that's how the antioxidants work. The vitamin C of this lemon plus the acid have neutralized that browning reaction. They've stopped the oxidation because vitamin C is an antioxidant. So that idea that antioxidants can slow down molecular damage is why there is hope that antioxidants in human diets can slow free radical damage and perhaps extend the healthy life of our cells and perhaps the healthy life of ourselves. So what do we eat that is rich in antioxidants? Well, we can chemically synthesize some of those antioxidants, and we can sell them as supplements. Vitamin C and vitamin E can be purified and sold as high concentrated antioxidants. Resveratrol is another antioxidant. It's actually purified from grape skins. But there is evidence that high doses of some supplements, even if they're antioxidants, can promote some diseases. For example, high doses of vitamin E can increase risk of prostate cancer and one form of stroke. And most major studies of antioxidant supplements in populations show that supplements did not reduce the risks of chronic diseases such as heart disease or cancer. Dietary supplements in pure forms can interfere with some medications as well. So if you're considering taking dietary supplements, talk to your doctor or your dietitian to see how they might help you or how they might not. On the other hand, rigorous scientific studies do show that a diet containing lots of antioxidant-rich foods, especially eating lots of fruits and vegetables, does correlate with low risks of chronic disease. It's not really clear why the antioxidant-rich foods do correlate with disease reduction, while pure antioxidant supplements do not correlate with disease reduction, but at least we know that these antioxidant-rich foods do. So why is that? Well, we know that nutrients work together. So perhaps it's the combination of the antioxidants in these foods and the other nutrients present in fruits and vegetables that give them such great health benefits. We call these super nutrient-rich foods superfoods, and they pack a great antioxidant punch, and they provide other nutrients we need for our metabolism. Because they're unusually high in nutrients per calorie of food you can eat, as you eat them, you're getting a much bigger nutrient bang for your calorie buck. Here are some examples. In fact, one of the foods highest in antioxidant concentration is blueberries. In fact, wild blueberries are packed with antioxidants. Red berries, like raspberries and strawberries, also have a great amount of antioxidant, particularly one called ellagic acid. Purple and red grapes are rich in anthocyanins and resveratrol. Beans and nuts also have strong antioxidant powers. Nuts such as walnuts and pecans, but also cacao, the solid product of the nuts of Theobroma cacao, the cacao tree that's used to make chocolate. Cacao is very high in antioxidants. Dark green vegetables, in addition, have a high concentration of antioxidants and other phytochemicals that are known to work in combination to promote long and healthy lives. So, that's where the phrase "eat your rainbow" comes from. Very often the antioxidants are pigments, and that combination of nutrients in these fruits and vegetables packs the most antioxidant punch. So there you have it. We are powered by a beautiful set of biochemical reactions together we call metabolism. And one of the consequences of metabolism is production of free radicals. We may be able to slow cellular damage and perhaps some effects of aging by eating foods rich in nutrients that are high in antioxidants that neutralize those free radicals and that can contribute to aging. So for more information on antioxidants, come to sciencewithdrbob.com. And until next time, keep on experimenting.